we know a vector has a magnitude or length and a direction. In this section, we're going to learn how to find the length of a vector. So let's jump right in with an example. Consider the vector v equals 4, 3. Find the magnitude of the vector. Now remember, the components of the vector is the position of the tip of the vector when expressed in standard position, when drawn in standard position. So let's draw this vector in standard position. So with its tail at the origin, we're going to go 4 out on the x and 1, 2, 3 up on the y. And so this is our vector here, 4, 3. And we just want to know the length of the vector here, the magnitude of the vector. Note that's equivalent to asking what is the distance from its tail to its tip. Okay? Well, for that, it's a distance, so we can use the distance formula. So using the distance formula, the magnitude of this vector is going to be the square root of x component of the tip minus x component of the tail. It's at the origin, so that x component's 0, squared, plus the y component of the tip minus the y component of the tail. And so we could see, because we are subtracting 0 in both these calculations, and that will always be the case when we express this in standard position, because the tail is always at 0. We get 4 squared plus 3 squared. Okay? Just the sum of the squares of the components of the vector. So in this case, that's square root of 16 plus 9, which is square root of 25, which is 5. Okay? So what we've seen here is that to find the magnitude of the length of a vector, all we need to do is take the square root of the sum of the squares of the components of the vector. Now, that's how it works in 2 dimensions, and generally that's how it works in higher dimensions also. The same rules we see here apply for higher dimensions. Okay? Let v be equal to the vector v1, v2, all the way to vn. And this will be a vector in Rn, an n-dimensional vector. Okay? Notice we're being abstract here. So the components of the vector are v1, v2, all the way down to vn. Right? So n could be any number here. So how are we going to calculate the magnitude of the vector? The magnitude of the vector is, and we have a special notation for magnitude. We have a double absolute value bar. This means the magnitude of the vector inside. These double absolute value bars, we call this the norm operator. So this is the norm of v. And the norm of v gives the magnitude of v, or the length of v. And so all we do is we take the square root of the first component squared plus the second component squared. And you keep on doing that until you get to the very last component squared. Add them all together, take the square root. That will give you the magnitude or the length of the vector for any vector in any number of dimensions.